All right, more limits. Hi guys. We're gonna talk about properties of limits and then how you can use them to evaluate um, limits that have kind of these addition, subtraction. It's kind of similar to remind you to what we did with logs at the end of last year. Let's see. Okay, so we're gonna start. I'm gonna try. My purple pen is just the brightest one. I wanted to go with a different color, but I'm gonna stick with purple for right now. My other ones are highlighters. Okay, so let's say you are evaluating a limit as x approaches a of f of x, and that limit equals L. Okay, and then you're evaluating another limit as x approaches a, same value, but it's of the function is g of x, and that value is m. Find each of the following limits in terms of L and m, right? So that just basically is saying to help us with having to write to simplify the properties. So basically, if I'm taking the limit as x approaches a and I'm adding two different functions, that's the same, sit down here, that's the same as saying the limit as x approaches a of f of x plus the limit as x approaches a of g of x. And we already know the answer to this is L, and the answer to that is m. So you can just simply add the answer to both limits, right? And you will have your answer. So that's the first property. You can find the answer to those separately and add them, and then you'll have the final limit. Same thing when you're subtracting them. This becomes that. Subtract. The limit as x approaches a of g of x, and it's just L minus m. So those are the same, just kind of inverses of each other. The same is kind of true when you have two different functions. So f of x over g of x as x approaches a, you can think it's the same as this. Which just equals L over m. The value of that's L, the value of that's m. Guess what happens when you multiply them? I can write it all out, but you end up going, it's just L times m, so I can evaluate these separately and multiply them. Now what happens if there's a constant in there that you can pull out? So this is the same, I'm going to write this one, as saying the value of the limit as x approaches a of that constant times the value of that limit as x approaches a of f of x. So guess what? The value of a limit of a constant, if you had to find the value of a limit of, say, the number 5, if the function is y equals 5, the value of that function is always 5, right? It's just a straight line, so you can take that out. So that just equals c times the limit as x approaches a of f of x. You can always take the constant out of a function, which then if this whole thing equals L, it's just c times L. All right, what if there's a power in there? So this is the same as saying I'm going to take the value of that limit and just raise it to the power p, right? And if the value of this limit is L, it's just going to be L raised to the power p. So you can take the power and apply it to the final solution. And this is exactly what I said up here. If you have to evaluate the limit of a constant, so this could be like the limit, it's going to be 12, right? So this is always just equal to that constant. It's a linear function. This is just an example. Okay, so we're going to use these to solve some problems. Flip to my next page. All right, so here we've got a graph of f of x, here we've got a graph of g of x. Find each of the following limits applying the properties of limits. If the limit does not exist, we're going to say why. Okay, so we have as the limit of f of x as x approaches 2 from the left plus the limit of g of x, same thing, x approaches 2 from the left. So we're going to split this up. What is the limit as x approaches 2 from the left of f of x? 2 from the left, the value is 3. Now let's do the same thing from the left, wrote the wrong thing, but of g of x. Okay, here's g of x. Where in the world is 2? It's right here. From the left, it's approaching 1. So the value of this limit is going to be 3 plus 1, which equals 4. All right? Let's try this one. The limit as x approaches negative 1 of 2 times f of x minus 3 times g of x. So we've got those constants. We can take them out. So we're going to do this. 2 times the limit as x approaches negative 1 of f of x minus 3 times the limit as x approaches negative 1 of g of x. All right, so what is the value of the limit of f of x as x approaches negative 1? I come over here, negative 1. The value is negative 6. So this is negative 6, and we still have that 2 there. Take away 3. Now let's find this part. What is the limit as x approaches negative 1 of g of x? Negative 1 is here. I come on the functions right here. G of x is equal to negative 1. That's negative 1 on the graph. So now I just need to evaluate that. This is negative 12 plus 3. So that whole thing comes out to be negative 9. Okay. So this is looking very similar to the first one, except there's a minus, and now we're looking at negative 3. So let's evaluate them separately. Let's look at what is the value of f of x when x approaches negative 3. So we come here, here's negative 3, it's right there. The value of that function is negative 2. This part is negative 2. Okay, what about g of x? G of x at negative 3. There is a vertical asymptote at negative 3. One side's going positive infinity, the left-hand side's up, the right-hand side's down. So this whole thing does not exist. So we have negative 2 take away does not exist. Well, we can't do that. So we would say this limit does not exist because g of x has a vertical asymptote at x equals negative 3. There's our reason. Okay, let's check. Let's move on to this. So now we have a division, negative 2 times f of x over g of x, and we're evaluating the limit as x approaches 6. So I know I can take that constant out. So I'm going to do negative 2 times the limit as x approaches 6 of f of x all over g of x. And I'm just going to squeeze some stuff in here. So this is negative 2. What is the limit as x approaches 6 of f of x? Here's 6. Both sides are approaching negative 4. And what's g of x at 6? Here's 6. Go up. Both sides are approaching 6. So that comes out to be negative 8 over 6, which ends up being negative 4 over 3. Sorry, that's all positive. 2 negatives multiplied wrong. So the answer here is 4/3. All right, what about as x approaches 4, 2 times all of that? So this just means we can evaluate the limit at 4 for both of these and then just multiply it by 2. So what's the limit of f of x at 4? Come to 4. F of x is negative 3 times g of x at 4 is 4. And we have 2. So we're really just figuring this out. So this whole limit comes out to being equal to negative 24. What about the power? So we're figuring out the limit as x approaches negative 2 of f of x, and we're just going to square this whole thing. So as x approaches negative 2, here's negative 2. The value of that limit is negative 5. So we are squaring negative 5, which is 25. So this whole limit is equal to 25. All right, now we're going to look at a root. The limit as x approaches 2 from the right side, square root of 2 times g of x, okay? So I'm just going to treat that root like a power, so I can rewrite it like this. Right? The 1/2. Okay, so now let's go ahead and figure this out. What is the value of the limit when x approaches 2 from the right of g of x? So let's look at here's g of x. 2 from the right side, it's approaching 6. Okay, so we know that the value of this part right here, let's try to find it real quick. is 6. And we have this constant here, so we can just multiply by that, right? So this ends up being, if you want, you could rewrite it like this. This is all to the 1/2. But we also took that 2 out, so it's also to the 1/2, right? So you can put the brackets around the whole thing. But I'm basically dealing with this 2 times this 6, and I'm square rooting it, which ends up being the square root of 12, which, if you remember, you can simplify into 2√3. So that's the answer for that one. All right, so now we have the limit as x approaches 2 to the right of f of x over g of x. So we just need to figure out what 2 to the right of f of x is and 2 to the right from g of x is. So let's look. 2 from the right side of f of x, it is approaching -2. 2 from the right side, here's 2 from the right side from g of x. It is approaching, what is it approaching here? It's approaching, there's 2, it's approaching 6 right there. So it ends up -2 over 6. All right? Which you can simplify to -1/3. Okay, last one. The limit of f of x minus g of x as x approaches -1. So let's look. X approaches -1. Here's -1. I go down. The value of that is 6. Take away, what's the value? The limit of g of x at -1. Here's -1. When I go down, it's -1. So this whole thing is 6 plus, oh, I forgot my minus here. -6 minus -1 ends up being -5. Okay, so this is really nothing new today in terms of evaluating limits, and I'm sorry if the graphs were hard to read, but just know that all I did to get these values was pull them off these graphs, okay? And you're just going to keep practicing your algebraic properties, algebraic evaluation, but using the properties of limits. Okay, see you next time with some trig.